change of velocity. We know that for a body in uniform motion, it covers equal distance in equal interval of time. That is, whenever you draw a graph between time and distance for a uniform motion, you get a linear graph. We have seen this, right? Now, can you tell me, is the velocity changing with respect to time? Can you tell me what is the velocity at this point and what is the velocity at this point? To find the velocity, we need the distance as well as the corresponding time. Whenever you take the velocity of every instance of time in a uniform motion, you get the same velocity. That is, the velocity is not changing with respect to time. You call that a uniform velocity. Now, what if we consider a non-uniform motion? Then you get a graph which is anything other than a straight line, right? Now, whenever you take the velocity at different instance of time, we see that for different instance of time, the velocity will be different. That is, there is a change in velocity with respect to time. Or you can tell this rate of change of velocity as nothing but acceleration. Acceleration is nothing but the measure of change in velocity with respect to time. Consider an object which started moving with an initial velocity u and ended up with a final velocity v. Then we can define the acceleration a as the final velocity minus the initial velocity divided by the time that it takes to change its velocity. Therefore, acceleration is nothing but the change in velocity divided by time. Now, from this formula, we can define the SI unit of acceleration as velocity's SI unit is meter per second divided by the times SI unit is second. Therefore, the SI unit of acceleration is nothing but meter per second square. Then what do you mean by negative and positive acceleration? Negative acceleration is whenever the acceleration of the body is against the direction of its velocity. That is, whenever an object is moving in this direction with a velocity v, if the acceleration is against the body, then it is a negative acceleration. Then what is a positive acceleration? That is, whenever an object is moving with a velocity v in this direction and the acceleration is given in this direction, then it is a positive acceleration. Now let's do an activity. Can you give an example for acceleration in the direction of the motion, acceleration in the direction opposite to the motion, uniform acceleration and non-uniform acceleration? Let's see. For acceleration in the direction of the motion, let's consider a car in which we are traveling. Now, what happens when you hit the acceleration pedal? The car suddenly accelerates or the car changes the velocity quickly. That is the meaning of acceleration, right? Now, see here. If you are giving an acceleration in the direction of the motion, the car's speed will increase, and this will be an example for an acceleration in the direction of the motion. For the second example, that is acceleration against the direction of the motion, we have to know something. We know that our Earth has a gravity around it, and whatever is falling onto Earth falls with a constant acceleration, which is 9.8 meter per second. Now, let us consider a ball thrown up. Isn't the direction of the motion against the direction of the acceleration? Yes, this is an example of acceleration against the direction of the motion. For the third example, that is uniform acceleration, we'll take the same example where the ball is thrown up. What happens after going up? It comes down. And whenever it comes down with a constant acceleration because of the acceleration due to gravity. Now, this constant acceleration can be defined as uniform acceleration. And this is an example. That is, a ball under free fall is an example for uniform acceleration. For the fourth example, that is non-uniform acceleration, let us consider we are traveling in a car in a crowded region. That is, there are so many pedestrians on the road. For example, a market. What happens? We will try to move the car very slowly. Then suddenly if there is way, then we will give acceleration and drives the car very quickly. That is, the change in velocity will be different at different instants of time. Therefore, this is an example for non-uniform acceleration. Always remember this. Whenever the velocity of an object is uniform, then obviously the acceleration in the object is 0. And whenever the velocity of an object is non-uniform, then the body is accelerated. Can be positive or negative. Whenever there is a non-uniform change in velocity, then you call the body as accelerated body.